Okay, so looking at simple interest's much better cousin now, compound interest. So the difference between simple interest and compound interest is whereas simple interest was a percentage of the original amount, compound interest actually changes each time, and we calculate the interest on the balance of the loan or the investment. Okay? So this means the amount that we're paying interest, assuming we're, say, increasing our investment, if we're putting money in, the amount of interest that we get is more, rather than it just being a constant amount for simple interest. So this is the formula here. It also has this form here when you include this bit here, which is where we're finding how much it increases by. So this A is the amount. So this is different to the simple interest formula where we're just finding the interest. This is the amount, which includes the principal and the interest. Okay. Then it's the principal times this little bit here to the power of n. And this is pretty much our recursion rule for the nth term for a geometric sequence. Okay. Where this a here was the initial term. And this r here was the common ratio, which was the same as this bit here, 1 plus r%. And then this n up here is the number of compounding periods. Okay, because not often, we sometimes do calculate annual compound interest, but more often it's a monthly thing, say if it's for a house loan, or if it's a daily thing, if it's a credit card loan. Okay, but generally this is the form of the equation that we're using. And just like before, our interest rate is usually expressed as per annum, but if we're compounding in monthly or fortnightly or daily frequencies, then we need to change that interest rate to match that. All right, so let's do an example. Okay, so trying to find the amount of money owed on $10,000 after 2 years, where we've got an interest rate of 10% per annum and we're compounding annually. Okay, so pretty straightforward application of the formula here. So $10,000, 1 plus 10 on 100, 2 compounding periods, and we're compounding annually, so that's 2. And this gives us $1,200. And remember, the amount included the interest as well. So if we want to find just the interest that we owe, it's just the difference between the principal and the value of the loan or investment, which is pretty easy to see from this one. It's just $2,100. Okay, so next one is same question, but I'm going to change one aspect of it. Instead of compounding annually, we're going to be compounding monthly, which again is a more common way of determining interest. So there are a couple of things that we need to do differently. So formula stays the same, but we need to change our interest rate. So instead of 10% per annum, divide that by 12 to get 0.83% per month. Okay. We also need to figure out how many compounding periods, because if we're doing it every month, we're not doing it twice. We're doing it once a month over 2 years. So that's 12 months in a year times 2, 24 months. Okay. So now we can do this. We've still got $10,000, but now using the other interest rate and to the power of 24. And that gives us that amount there. Then just determining the interest, it's just the difference between the principal and the amount, is $2,203.91. So if we compare that with this one up here, we can see that compounding annually, monthly in this case, has given us an extra $103.91 compared to just $2,100 extra. And this is why we compound monthly, is because the amounts end up coming larger. Now, you're going to have a go at this one here. Again, same style of question, but I'm changing this instead of annually and instead of monthly, now daily. Say this is a credit card loan. Figure it out. Okay, so again, the two things we need to change are our interest rate. Now we divide it by 365 days in a year, which gives us a rather small percentage. And then the number of compounding periods is just 365 over 2 years, which is 730 years, 730 days. And then into the formula. Which ends up giving us this amount there, which means the interest is that there. And again, it's higher than the original one. Not as significantly, only looks like by just about $71 or so, but still more. So here's the question. What can you say about compounding more frequently? So imagine if we were maybe to compound hourly or even by seconds or minutes, we'd end up with a lot more money after that. But in general, we just restrict ourselves to months, fortnights, and daily compounding. Okay, so just to summarize, compound interest. Interest is calculated on the balance instead of the original amount, which was for simple interest. We've got our formula here, which is very close, or it pretty much is the same thing as our geometric sequence nth rule. And went through a couple of examples here, just noting the fact that A also includes the principal as well as the interest. So if you're just interested in the interest alone, you need to take away the principal. Then if we're compounding in other frequencies other than annual, so for a month, we need to change the interest rate to something that's a per month interest rate, and also determine what the number of compounding periods are. And then we noted that the more frequently we compound, the greater our amount becomes.